Um, we'll continue our discussion of control systems by looking at a very simple automatic control system. And I want you to start the discussion by looking at position control systems. So, this is a control system which controls the position of a motor in the desired place. Okay, so let's say we have a motor here. So, this is a motor, and this is, let's say, the reference direction, and what we want is we want to hold our motor in this particular direction that I'm drawing. Okay, and whatever this direction is, so let me call this the load. So I want this motor to be I or let's say it's a knob. Okay, I want this knob to be in this position all the time, and this knob is basically controlled using a gearbox and a motor. So this is a motor which controls the position of this knob, and it is connected to the knob by a gear through a gearbox. Okay, now if I now the input to the motor is going to be a voltage, and if I apply a voltage of greater than 0, let's say the knob actually moves in the counterclockwise direction, while if I apply, so let me write this, v greater than 0, it's a counterclockwise rotation, and if you have v less than 0, it's a clockwise rotation. So the knob rotates in the clockwise direction. Okay, so now I want to control the location of this knob by using a control. So let's say I have a small control here. Let's call it a control knob, and depending on whatever my control knob's direction is, so if that is theta, and let's call this theta d for desired, so whatever the desired angle is, I want this angle theta to be the same as the desired angle. Okay, now of course the problem is, I mean, one of the things you could do is you could just connect this knob to this motor and control this, right? Why? And that probably would work. But what it does not account for is all the variability in your system. For example, you could have some disturbance, you could have some noise associated, or this load. Let's say I'm trying to push this load, right? As long as this is theta d, I want this to be maintained at theta even if I'm pushing it. So if I just connect this knob and just convert this angle somehow into voltage and give it here, that's not going to maintain it in the same position. So I want to be able to compare these two angles and use the error to either rotate my motor clockwise or counterclockwise. Okay. So how am I going to do that? So what I'm going to do is I'm going to introduce a controller in my block diagram. So here's a controller. Okay, I need a pen. So here's a controller. Okay, so let me write it here. This is a controller, and what it does is it reads theta d on one side, and on the other side it reads the value of theta. And let's say somehow you get the value of theta, probably you put a sensor, an angle sensor, to measure the angle theta, and it gets both these values. It subtracts these values and calculates the error. Okay, and let's say it also gives a gain to that error. So the output here is going to be kp times e, where e is the error, and this error is given to an amplifier, basically because you want to convert the voltage kpe into a voltage that can actually be fed into the motor. So probably this amplifier is just a high current amplifier, so it takes the voltage and the gain is equal to 1, and all it does is it increases the amount of current so that the amplifier can actually run the motor directly. Okay, and And of course, let's also draw the sensor so that we are clear. And let me just erase this, and let's put our sensor here. So somehow you have some kind of an angle sensor here that gives you the value of theta. Okay, so now let's think about what happens in this control system. Let's say initially that theta d is greater than theta. So if theta d is greater than theta, what happens to the error here? The error is positive, right? So if the error is positive, the v is greater than 0. If v is greater than 0, what did we say about what happens when v is greater than 0? We said that the knob is going to move counterclockwise. So this knob will move in this direction, which means that it is going to bring it back to theta d. Remember, theta d is, we started off by saying that theta d is greater than theta. So basically what we had was, let's say this was theta, and this angle here is theta d, right? So because the error is positive, this v is positive, and if this voltage is positive, theta increases and tries to reach theta d. Now let's take the other case. If theta d is less than theta, what is going to happen? Let's draw that diagram here. Okay, let's say theta d is less than theta. What happens? Let me erase this just so that we have some space to. So this means that this angle, let's say this is the reference direction, this angle is theta, and let's say this is theta d. Okay, so what happens to the system? What happens to the error here? If theta d is less than theta, the error is negative. And if the error is negative, what happens to the voltage here? This voltage is negative. If the voltage is negative, in which direction is the motor going to turn? It's going to turn clockwise, which means that this angle is going to go again closer to theta d. So can you see how the control system is actually trying to keep the theta nearer to the desired angular position, which is given by theta d. Now let's say this control system is working, and what I do is I come along, and because not I'm just angry, so I just push this knob down. Okay, I push this knob this side. Now as soon as the knob is pushed, what is going to happen to the angle theta? The angle theta is going to become less than theta d, and then the control system tries to bring the angular position back to the desired angular position. So in that way, we have a position control system. We have a control system that controls the position uh, of the knob to the desired angle, to the desired position that we want.